Yo, Geo, where's the gang at? What's up, Larry? Bro, I guarantee you're gonna get interrupted later. Don't freak out about it, man. We'll do the best we can.
I am going off to put 6 new cell sites into the network. So I'm going out to meet up with the teams out in the field. We're going to radiate the hell out of some more people. Been on the road for an hour. These are some of my closest cells. I'll also be traveling through shitty areas, shitty coverage areas.
You gotta just put cell towers up as you go.
That's kind of what I'm doing. Well, I've been trying to make up 6 minutes, running 6 minutes late. I've been speeding the whole way, and I can't make up the 6 minutes.
Oh, dude, it's so hard to make them minutes back, bro. You gotta really
Yeah,
bounce, man. You gotta really fucking float.
well, I've been averaging over, 10 miles over the speed limit. And it's like, well, over 70 miles, that should add up to quite a few minutes. It's like,
This should be 10 minutes over an hour, you would think, right?
yeah,
Like
yeah,
if you go 70 an hour, instead of get to 60, you make 10 minutes up, man.
yeah, covered 10 more miles. It's almost like Google is counting on the fact that I'm good speed.
Yeah, right.
You know you do it. You all do it. Like, damn it. I got to do 70, 80.
We should just have a lane. I mean, dude, the left-hand lane on the highway, bro, no one's turning off. No one should be stopping. It should be like the Autobahn.
This is all 55 miles an hour and skinny roads with deep ditches on either side and twisty, turny roads.
Well, yeah, not there, but
And it's crash. You're waiting for somebody to be tired and sleepy and drift over the line. Tired and sleepy.
bro, if we ever get the money or the time, we gotta do that test. We flip the Seattle like back.
Larry sounded like he was. He said something the other day like he was really starting to like the idea of it. So it's like trying to get him self motivated. And then if he's self motivated, then I'll drive up and carry shit for him at once.
Literally, all you need is a guy that and the tool and that knows how to use it, and you can get that shit done.
Yep.
Like you need, it's not like you need some crazy expensive thing with a whole team of dudes and shit. You know, maybe you need a helper.
It does get a little expensive, but if you rent, you could rent the equipment, for. I have no idea what it rents
That
for, but I'm
one,
guessing $1,000 for all the equipment.
Larry owns this shit. He owns it.
Yeah. Well, that's if you get Larry.
Well, dude, he's not the
Then
only
it's
one in our. He's not the only one in this arena that owns that tool.
yeah, but he's the only one competent.
I don't know about that, but there's definitely other people that could use this tool. I mean, heads are running around acting like we don't need to make a straight line and not change the level on it because you guys say it's changing your vertical.
Yeah, I think the unusual things are like Rakia won't do it because he doesn't believe in the methodology. He can't jump outside the box to uh, do things
Yeah.
not the way they're normally done.
I mean, of course
That
it's going to be. Of course, it's going to be something done not the way it's done. Because if that was the case and it was always done, this wouldn't even be a thing.
right. Well, it's not a thing. I mean, the way they do it is sufficient, but
Yeah, that's what
we're
I
in an
mean. Like,
arena
no,
where
I mean this
we're
whole arena
questioning,
wouldn't be a thing. Go ahead.
right?
Like if they
Well,
did it the way we're saying, this arena wouldn't even be a thing because I feel like that's definitive shit.
right, but it's more than definitive for everybody else. This is purely because somebody's trying to be hyper skeptical and not understanding the methods that are in place are sufficient, if nothing more than logic. We don't always go back to absolute bullet. And when you take the body of evidence and everything that all aligns with globe, all of it's, I admit, all of it is not absolute. No measurements are absolute. But the fact that they all align
Yeah.
and come to the same answer is, that's good enough for me.
I don't know about that. Not all measurements are not absolute thing. If I put a tape measure to my a 2x4 or something, I have that shit's right on the line. It's on the line. Yeah, it may be a little bit more, a little bit less, but we know that it's 10 feet long.
Right, but now if you take 100 measurements of 2x4s and you say, yep, they're all 8 foot, and you stick them end to end, you'll find out that, you know what? Some of those weren't quite 8 foot.
Yeah, but the one I measured though the first time was 8 foot.
Yeah,
And
but
then you
like I
could
said,
take another one and
the
be like, oh,
precision of it varied.
yeah. Then you could take another one and be like, oh, this is 8 foot 1 inch, or this one's 7'11".
No, I'm saying you measure them all and say, yes, they're 8 foot. Your tape measure, let's just say you're measuring with a yardstick. Yeah. Or, and you're off by, I don't be off by 1/8 of an inch on each one.
Yeah, you could be off 1/8 an inch, but you would know that it's definitely not 11 feet. You would know it's not 9 feet,
Right.
or
But when you add up all those
seven
those
feet.
measurements, yeah, when you add up
I'm
all
just
those
talking about
measurements.
one board, just one board, bro.
Oh, yeah.
Yeah, you can measure one board and be like, all right, this is definitely not 7 feet. It's definitely not 9 feet. It's eight
Yes.
feet. It may be 8 feet in a nanometer, but it's close enough.
And that's what we've got with the measurements we have. It may
That's
not
what you
be
think.
exactly, but it's within an arc second.
It's a guess, bro. It's a guess.
Oh, when you say
You don't know.
guess, that's a really bad terminology.
It's
It's
an
not a guess.
educated guess. It's an educated guess on which way the light's bending.
Yeah, you can even eliminate light bending from the equation. You'll still come up with curve.
If you do it in a vacuum,
No, you'll
how are
still
you
come up with it
eliminating?
being curved because it never, or very rarely, does refraction ever eliminate the curve. We've got one photo so far, and that was
How
under
did you
extreme conditions.
eliminate the light bending?
You don't. We know light bends. There's no question about it.
All right.
However, it always shows curve, or virtually always shows curve.
I don't know. I thought you said you could get rid of the light bending somehow.
No, I say you live. Oh, okay, I did say that. Hang on, my navigation's thrown at me. Okay, you eliminate it because it's not significant enough to eliminate the curve. It's just
I
less.
know that's what you say. That's what you say, but you don't know how the light's bending. You don't know which way the light's bending now.
Well, we have a convention that seems to be pretty good, which has that denser medium. Light bends down towards denser medium. Do you have any exceptions to that?
That definitely happens in fish tanks. Yes, over long distance in the
No,
atmosphere. Is it bending down?
do you think it isn't?
I don't know. But you also need a curve for your refraction to work the way you think it does. So you say we know how refraction works, and
Is
then you
there a curve
take
in the
those
fish
curves.
tank?
When you
Oh
have
boy,
optimal conditions, the refraction is
oh, go ahead.
negligible.
Um, negligible. The deviation from standard refraction is negligible.
So then,
Standard
what do
refraction
you
is kind of
call?
like you're starting.
What's the measurement? So what's standard refraction at 10 miles, 5 feet observer height?
I don't know the exact number of it. Should, but I don't. It's total refraction. It seems to range up to about a half a degree. That's like
Half a
on the
degree.
extremes. Yeah, that's like on the extremes. Standard plus some anomalous, but I could be wrong on that. It could be half a degree normally. I used to know this.
So like without being exact, half degree would probably serve you in the short distances, but like long distances, you'd be blown out of the water. For example, the Canigou, the 275-mile mountain, your half degree takes a shit right there, doesn't it?
I don't know how much is Canigou off at those distances. You're probably talking about a few arc seconds.
I'm taking your half degree. It's not going to work over
Right,
275 miles.
right. But all you need is a few more arc seconds to get those mountains up.
Well, I have to look at those numbers to see what you're
Yeah,
talking about. More just in general talking, I don't think it's going to work.
yeah. When you're talking like, dude, I don't even have the number for this, but if you do a angle
Listen,
over distance, and you try and figure out what's going to happen at 200 miles, how far do I have to go to raise something up 2,000? 3 arc seconds, 4 arc seconds, a flea fart.
let's say we wanted to be critical. We wanted to question your how you said your refraction happening, right, which is going to affect what we see. How do we confirm that it's refracting the way you say it? That it's refracting down. How do we confirm that's really happening?
Well, there's 2 ways. There's the way that I've been talking about with Jeremy, that we can validate that the Earth's surface does actually curve a theodolite force aligned situation. And then the other way I think is reasonable. This is a more logical deduction. But if I take the sun, the known rate the sun moves per hour, and I calculate and I look at it as it traverses the sky, as it gets down towards the horizon, I should assume that 15 degrees per hour is continuing, 15 point whatever. And if it doesn't, then I know that the sun has refracted in a direction. It is slowed down because of the light bending downward.
But that's not
So
from what you
I
said.
could actually determine whether it's refraction causing the sun to happen or not. You gotta assume that since it's 15 degrees per hour every other time of the day, except when it gets into that zone, that it's still 15 degrees after it gets to that.
But that's not really a confirmation. That's not really proving anything. You're explaining
Well, I said it's deductive.
15 degrees, and then you're matching it up to what you think it would be.
Right. That's a deductive thing. If there's a car driving past you at 50 miles an hour, you can assume that it's going 50 miles an hour after that. Now, cars do vary in speed a lot, but we also have confirmation from people standing downwind that the sun didn't slow down when it got to the horizon. It actually continued on its speed. So we know that it always travels at that speed. plus or minus a fraction of widths and like. So if the sun always moves 15 degrees per hour for everybody on Earth, except in that zone, I'm going to say that's optical. Just logically.
Jeremy, I didn't mean to cut you off. Were you going to finish up?
Dead deer.
You say you know how refraction works, but you have to put it through a curved gradient for it to even work like that. So you're already saying we know it's a curve, and then the light's bending through this curve, so we're going to tell you it's a curve, like it's circular reasoning.
Well, we see that even on a dead flat surface that refraction happens. So I don't know that that's an entirely true statement. Curve is something that you have to factor into it. But if you look at the fish tank, the gradient is sufficient to make the light bend.
Yeah, if the light bends, I'm not doubting refraction happens. I'm telling you that when you look at something and say, "Oh, we know how refraction works, so this is its actual position," you're saying that it's going through a curved gradient when that happens. You get it?
Right.
Yeah.
I don't know how big the impact of the curve gradient is over just the fact that it's a gradient, because you're looking down through the gradient to the horizon.
Refraction can only work the way you guys say it does, and you can only have the things going on that you say it does if it's going through this curved gradient.
Oh, no, I understand. But I'm saying that we saw in the fish tank that light bends down in the fish tank
Yeah.
into the denser medium. So even if it was dead flat, they would still bend down.
Well, maybe if that's how it's working
It's how
long
much?
distance. If that's how it's working long distance over the atmosphere, maybe.
Do we have a
If that's
gradient
not
over
how
the, as a rule, do we have a gradient with densest on the bottom in the atmosphere?
yeah, but there's a lot of other effects going on. It's not just a fish tank. I can measure how much water's curving in a fish tank. You're not going to be happy with that, are you?
No, absolutely not. I'm not saying you get bulletproof. These are things that you can just, as a layperson, can deduce. We know, deduce and observe. We know that the gradient is almost always densest at the bottom in the atmosphere. There's some variations, but generally speaking, what we are experiencing is more pressure at the ground level.
Okay, and then there could be other things going on too, other effects in the atmosphere that's causing that to go some other way.
One question is how much would light bend in our atmosphere? Because let's look at what you say. You say it's getting denser at the bottom, but like if we took like a barometer, right, from like I don't know 5 feet of observer height, it's the same, right? It's the same from 5 feet to the ground. If it is the same,
What was that? Wait, stop for a second. What is that? Say
we
about
take
5 feet?
take a barometer.
Yeah.
It's the same from 5 feet to zero, is it not?
No. I can measure it every with my phone. I can measure differences at 6 inches, even with a piece of shit phone that I have.
Okay, so what's the difference in 5 feet to zero?
5 feet to zero. What is that like? I can't remember. I don't know if it's
1%.
millipascals. It's 10 units. It's 10 units on the 100,000 unit scale.
So not even a percent different.
Correct.
If it's not even a percent different, what makes you think that it would bend down?
Looking through 10 miles of it, I don't know.
But like we said, let's say the 10 miles is the same as it is in your living room.
Right, it's got that
It's
same
not even
10%
1%.
variance. Or that same 1%
What
variance,
percent?
yeah.
What percent? What percent?
No, you were right. Like 1% variance.
It's 1%. That's not really going to make the light bend down.
I don't know.
I would say no. I'd say for light to bend down, you'd have to have, a substantial difference in the density. For example, like 50 feet or 100 feet to zero, that would be, you could probably, you can probably, that
Well,
would be a more deliberate,
but
more measurable amount.
what do you
5
think
feet,
the
like
over your car?
10,000.
Yeah,
Go ahead.
sorry. Okay. What do you think when you're looking at your car, and you look over the roof of your car, you see shit wibbling and wobbling 15, 20 arc seconds? What do you think the pressure differential is over your car? Think it's 2%, 10%, 15%?
I would say zero, and it's not because of what's over your car, because you're seeing something in the distance that there's heat signatures, there's cold patches, heat patches, there's wind,
Right.
right? It's not, it has nothing to do with what's over your car. It has to do with what's in the distance.
You think that my car, which I just moved in, I'm looking, I'm sitting at a traffic light and I'm looking off into the distance, and I see this top of this building right at the height of a car. Now a car pulls in front of me, and it's sitting now. The roof line is right at the top of that building, and now that building is wibbling and wobbling and jiggling around. How much pressure differential do you think is over that car? Because the car is the only thing that's
Okay,
changed.
so you're talking about like the heat coming off of your car hood, right?
Yes, the heat waves. Yeah, see those.
Well, I would say the heat coming off of your car waves would corrupt the it would corrupt the distant object. Yes.
Right, but why?
And that would
Or how
be,
much difference in pressure do you think there would be? Because if we're talking, you're saying that
I don't know about
you
the
don't think
pressure,
1% do it,
it's the heat.
but I'd say
I don't
that's
know about-
probably only like 2 or 3 or 4%.
Listen, I don't know about the pressure, but it's the heat. It's the heat that's manipulating what you see. So
Right,
you
varying
gotta
the
throw
density.
that's a fallacious example, because you want to throw that out because you don't want to do any observation around hot car hoods. You want to do observations where there's no heat signatures, where there's a minimal refraction. There's the clearest day possible with similar.
Oh no, I absolutely agree with you. What I'm arguing here is I'm trying to say that you said you don't think that 1% could make the observations that we see. However, when we look across that car, I see 20 or 30 arc seconds. Yeah.
Let me say it a different way. I don't think the difference between 5 feet observer height and 0, or 10 feet observer height, whatever the standard observer we're going to do over a lake, over the ocean, 10 miles, 20 miles, we're looking for curvature, we're shooting lasers, we're using our P900s. I don't think the medium we're looking through is any different from let's say 5 feet to 0 or 10 feet to 0 enough to bend light. I think the only thing you're going to see is what's out there under optimal conditions, and the only exception is if you have like this bad weather condition, heat signatures that's gonna that make the object blurry. You can have compression, different things, but the light refracting by itself, because density, I don't see that happen. I want to question it. How do I know that that's really happening? That's
Well, again, like heat signatures are just variations of density. I mean, that's essentially the only thing different about it. It's where the air is unstable, wiggling around and changing in density. And if I can get a change in density over my car to be able to change objects several arc seconds every couple of seconds, then I certainly think that 10 or 6 feet of atmosphere, 5 feet of atmosphere difference could be strong enough to make the changes. Oh.
I don't think you're hearing yourself, bro. I don't think you're hearing yourself. You're using heat to give an example of a perfect observation with really no heat. You don't want any heat in your observation.
No.
You want the water to be the same temperature as the air. You don't want any heat signatures. You don't want any kind of hot car hoods in your observation.
All right. I don't think you're listening to your own self, because what I'm hearing you say is you're saying that you don't see how 1% atmospheric change from the ground to my eyes, which is, I said, we came up with about 1%, which, maybe long, whatever number we use. So we say it's 1%. You say that can't do it. Yet the pressure differential, the density differential over my car in a 1-inch area is varying by probably something like 1% at most. Therefore, 1% is more than capable of making the observations of bending light.
Not without the heat. No, it's not. Not without the heat.
No, heat has nothing to do with it. It's density. I could do that with the same temperature air if I compressed air out of it and poof, like if I had like the equivalent of an air hockey table over my car, and I just puffed little cold. That would be cold. Just puffed air out so that it
I
came in at
believe
high pressure.
you're using a fallacious example. I don't believe you're thinking that through right.
Okay. I think you're using a fallacious example and you're not thinking it through right. So I guess we're going to stand
I didn't
still.
use an example. I didn't use an example. You're saying that over your car hood, there's enough density difference to have refraction happening.
Right.
And you said you're looking at a building. I'm telling you, the building is wobbly because of the heat from the hood. Nothing to do with density.
Yes. No. Whoa. You think that heat? Like, okay, so if I took that hood and I heated it up and I had the air above it be the same temperature, would it wibble and wobble?
Let me answer.
No.
Let me answer it this way: that wibbly wobbly thing. You want to eliminate that. You want to have any kind of observation with heat signatures affecting what you see. Period.
All right. I think that we're at a standstill because like I said, I'm saying that heat signature is density. Heat is the cause for the density change, but density is the cause of the wibbly wobbliness, not the heat per se.
But
I want to do an observation without
we know
heat.
that
I want to do an observation without wibbly wobbly stuff. Don't you get it? And you're trying to bring
No,
me right back
absolutely.
there. You can't. Your observation is for shit if you have wibbly wobbly stuff, man.
I agree, but you were saying that you, as a prerequisite, I can't think of the word, an assumption that 1% atmospheric difference between ground and your eye is not enough refraction to make things happen. And I'm saying that less than 1% refraction or a pressure change over just the surface of my car is able to make things move further than we would see with normal refraction under good conditions. Therefore, the variation I see between my head and my feet is enough to cause that.
Jeremy, are you there? Is anybody there to explain this? I don't understand.
Yeah, I'm here. I wanted to say something.
Go ahead.
I don't think the heat gradient like directly correlates to the density gradient. I think, I can't speak on it too much. I'd have to look it up.
No, there's a pressure there's a pressure gradient that comes from atmospheric pressure, and then you have heat, which is varying that atmospheric the density of that gradient by little bits here and there.
Yeah, there you go. They're just an effect on another. They're not going to always be correspondent, right?
Right. That's where you get wibbly wobbliness.
You all set, Godric?
No, I'm dumbfounded. I can't believe he's trying to pass this over on this. Let me ask you this: take a cardboard box. Okay, go to the beach. Put the cardboard box on the ground. Now this is going to replace your car hood. Now sit down, Indian style, on the beach. The cardboard box in front of you. Now you're gonna tell me that you're gonna see density gradient? You're gonna see wibbly wobbly stuff over the cardboard box?
Cardboard box. I'm a little confused as to why a cardboard box.
You can use a table, you can use a cardboard box, whatever you want. Just get away from that hood because that hood's gonna have heat on it. That's what I'm saying.
Okay, so you're saying something that doesn't have a huge temperature, like
any temperature.
Cardboard.
Listen, if you want to make observations, right? Real observations of distant objects, you gotta be away from all these heat signatures that are going to cause manipulation of what you see. So absolutely,
I absolutely agree with that. What I'm doing with my example is not saying this is where you test. I'm saying that I'm going back to the base principle that 1% atmospheric change between your feet and your head is enough to make the gradient is enough of a gradient to make things move.
How do
Because we
you measure
know
that?
that because we see an example of that in hold on, look for my ad exit here. We see an example of that in the fact that over your car, with teeny tiny little density changes, we see big changes in the background.
We don't see that over
So,
your car.
what's that?
You don't see that over your car. You have to turn the engine off. It has to be a cold hood.
Oh, for fuck's sake! You just can't get it. Sorry, man. I'm done.
Dude, you're using the fallacious
We're
exist.
just talking
Get
past
away
each
from
other.
your heat. If you want to make an observation, you have to get away from your heat. It's like this. It's like the globe where it's talking about.
Yes.
Oh,
I'm
look,
giving an
I have
example
butane.
of. I'm giving an example of how we know that that's enough change to cause what's happening. Not that it is a measurement of the horizon. It's saying that little tiny bits of density change can cause big changes in the background. That's it. Now we have a little tiny change from our feet to our head that's pretty uniform under good conditions. And I've met my people. I gotta go.
Jeremy, am I missing something? Jeremy, talk to me. Tell me I'm crazy.
I wasn't listening.
There's something
No,
I
you
wanted
didn't.
to say to all of that.
He was using a ridiculous example to try to tell me that the refraction's happening because of the heat over his car hood makes buildings wobble and distant. This is globe logic. I don't get it.
So I might be totally mistaken when I say this, but apparently, the farther you can see, that's supposed to mean that the that you're seeing farther because the light is being bent up and over the curvature of the earth, over the obstruction. So the hotter it is, the farther you can see. That's like, I think that's the claim of the globe model, but I don't know, don't quote me.
Yeah, the globe claims that we're not looking straight. We're looking over. We're seeing it's bending over a curve, and it appears to be flat, but it's actually curving because that
Yeah,
light is curving that from our eyes.
right. It appears to be flat because
The
the
really strange
image is
thing,
bending over the curved surface.
the really strange thing is the refraction is happening exactly to the measurements of this globe Earth to make us look like it's exactly flat when really it's curved. That's the strangest thing about it. It's like they couldn't come up with like a random, a number. The number is exactly to make us look like. That's why when you see stuff far away, it's actually not there. We're actually looking over a curve. It just looks like it's there.
Yeah, that's why they say that light bends through a medium. And they think that the atmosphere is so crystal clear and hot that it's bending light around the curved surface of Earth from like distances we shouldn't be able to see. If I got that incorrect, like I'm waiting for someone to correct me, but that's really what I think is going on.
Yes, you can take a tank of sugar water and get light to bend. Yes, you can look over a car hood that's heated and you can get buildings to wobble. Yes, if you have butane tanks, you can shoot some butane in over an object and you can get it to see over a curve. That's like a science trick. Nothing to do with real life observations happening. There's no butane. There's no heated car hoods. There's no, there's perfect. You want to get perfect conditions to make observations, and at least optimal conditions. At that point, I'm saying that there's no that refraction, that the amount of refraction that's happening is negligible. Can't measure it. Can't show what's refracting. What we see is what we see is because it's there. That's what I'm saying. No curving over a ball. No refraction happening. No butane tanks. No fish tanks. No heated car hoods. That's how you know, because you're testing something and there's nothing to tell you otherwise that it's actually bending.
Yeah, I'm with you.
Did you get that, Jeremy?
No, still wasn't listening. My bad.
And these globers, like Jesse, for example, he'll take crosshairs. He'll say, "Well, the horizon, the crosshairs are falling below the horizon, so that means it's curving." I'm like, "What?" And then who's the other guy? Ruhif will say, I have maps of the gradient. I have years of research, and this gradient's happening, and that's how we know that light bends to a curve. Nothing about testing it, nothing about proving it. Just his claim that we have a gradient because of all these weather balloons we've have data on, and the data shows me it's curving, but it doesn't show him it's curving. He's assuming that it's curving.
Is that what you wanted me to hear that I missed?
I'm just rambling, bro. I'm just trying to like the Globers have not showed me anything that's a satisfying answer. Just nonsense. And Moyak man telling me because my car hood can produce wobbly buildings, that means that the light can refract. What? Jesus.
Is what I said correct about light bending over the curvature of Earth, and that's why it appears level? That's why we see objects that should be obstructed, is because refraction is lifting objects up and over a curve. Like, I don't want to be saying this shit incorrect. I want to know I'm wrong or right.
Well, I mean, the Globers. That's kind of what the Globers say, but they generally. Well, see, my understanding is that Globers have to make up shit to make up stuff about how
Yeah.
refractions work, because otherwise, the science by itself does not defend the globe. Science by itself is not going to tell you about refracting over a curve at a distance. They're making up this shit to combat the flat Earth, right? And it's not really it's their own interpretation of, for example, their own interpretation of what refraction happens. They're getting very creative, make up this shit to claim that we're seeing over a curve. Different ways they can do that.
You
It's
know,
all very
B-Ball is
creative.
life. Do you know the dude B-Ball is life or Earth Science? I don't know his name, but he posts these images where he's in Hawaii. He's looking at some building. The building's shimmering. The water's obstructing the bottom of the building. And he claims that there's no refraction, there's no lensing, there's no atmospheric conditions, and that this is how the Earth always looks. And wow, just wow. That's wild. Clearly, those images that he takes they all have lots of like atmospheric conditions. I don't know, but you for the globe, you literally have to say that when you see curvature or when you see something obstructed from bottom up, that's clear crystal conditions. You're seeing what the globe's doing, and yeah, that's what you got to ride with.
Electric. Have you seen the picture of the boat and there's compression happening? And the way you know it's compression happening is because, for example, there's like a blue stripe paint on the bottom of the boat, and up close you see the boat, you see the hull of the boat, and you see that blue stripe of the boat. But far away, that hull starts appearing just to mesh with the horizon, or to sink into the water, or the Globers will say to be covered by the curve of the Earth. But when you look at this hull that's supposedly covered by the curve of the Earth, what you'll see that blue stripe across that bottom of that boat, but the blue stripe will be condensed down, smashed down, if you will, to where you can still see it, but it's condensed down, proving that it's not behind the curve. But the Globers will say, this is a curve. You can only see part of the hull of the boat. That means it's behind the water. It's bending around the curve. But you can see that blue stripe at the very bottom, condensed.
Yeah, I know which video you're
You know,
talking. You're talking about where they put the striped board on the water. I think that was Damn the Waterman, right?
It's just it happens a lot of different places. Anywhere where they're going to show a compression, but a compression is not the curve of the Earth, is what I'm saying. You follow me?
Yeah, I could post a whole bunch of stuff about that right now. I mean, you could do it on a football field. You could put a camera 6 inches above the grass on a football field and just walk away from it. Your legs will disappear, like as you walk towards the
There's,
other end of the football field.
hang on. There's a problem with that though. A football field, right? There's going to be patches. It's not going to be perfectly flat. I mean, it is flat, obviously, but it's not going to be perfectly flat to
Yeah,
where.
bad example because they literally hump the center of football fields to drain water, right? So I'll just anything else
I
though, like
wasn't going to say that.
table.
I'm
Yeah,
going to say that. All I was going to say is that if you did have a hump, right, whatever patch of earth, rock, whatever, and it's causing the floor to move up at least a little bit, that you would get the occlusion of objects because it's not perfectly flat, and that's why you should do it on water. Water, especially like a crystal lake, like a serene lake, because then that's the flattest condition you get without humps in earth, without like you said, water drains, so it's not be flat. I think it's better to do it over like a serene lake.
fucking. Just because Globers argue that an object can be obstructed bottom up, that it can't be obstructed bottom up, that doesn't make it true. People have already demonstrated you could put an object on a table and obstruct it bottom up using lenses. You just have to really hardcore ignore and avoid that information to keep your position, honestly. Yeah, the moment I was like trying to like learn about perspective and oh, why is this such a talked about argument? It took me 5 minutes to realize, duh. Like, of course, objects can be obstructed bottom up
You can
on the
actually
surface of it.
you
Yeah,
can actually take a checkerboard, right? And let's say checkerboard's flat. You can lay the checkerboard on a table, and if you put your eye very corner of that checkerboard, very low, what you'll see the first few squares perfectly fine. But then as you look farther to the other side of that checkerboard, you'll start to lose those other checkers. Those other squares are not visible, and that's because the angular resolution. That's because
yeah, compression. Closer to your eye level, things are being compressed.
and you can't make them out. So I'm not saying they're not there, but you just can't see them. So it's basically the distant objects are meshing with the horizon. That's why train tracks appear to meet in the distance. I'm not saying they really meet, but they appear to meet because they're going together on an XY axis, left, right, and that's the same reason why street lamps, which are the same height, angle downwards in the distance towards the horizon and vanish into the horizon. Not because the Earth is a ball and bending around that curve, but because that's those street lamps are vanishing in the horizon, and so is the train tracks. That's an up down axis. Train tracks, the left right axis, also vanishing. Street lights also vanishing. Everything's going to vanish. Checkerboards, everything's going to vanish in the distance because of this ability to see them. Is gonna end at some point.
I think you're right, bro. I think you're right.
So like our naked eye is like range one, and objects vanish from the naked eye. But then we use, let's say, F100. Now we're going to see range two. We can see farther. But they're also going to vanish at some point. Same difference, just farther away.
all someone that believes in a globe has to do is go to the Plain Truth YouTube channel and just watch that video where he takes the Tupperware glass and he obstructs the boat bottom up while it's sitting on a table. That should be enough for anybody.
Oh, and
If
did
you're
you see on the lake where they took those mini toy boats, not more than like 50 yards, I don't know, a couple hundred feet, and those toy boats vanished into the horizon at maybe, I don't know, 100 feet. Couldn't see the bottom of them. Did you see that video?
I gotta get a coffee.
Did you post something I can look at?
I'm sorry. The last person that spoke, what's your name? I can't look at the list.
It was Godric and Electric. We're talking. What's up,
No, no, you. What's your name?
Godric?
Godric. This is Rakia. Can I talk to you perspective wise? Like when we're looking out into the distance, let's use water because like that's the easiest. If we're looking out over a calm static bay, let's say at the time, or lake, and the water appears to rise towards our eye level. Do you agree with that?
I was never a defender of eye level because eye level will change depending on your height. I think that your height gives your height.
No, I'm talking about what
Example,
if you're 6 foot. If you're 6 foot at the land beach and you're looking out over water, it does appear to rise due to perspective. Do you agree with that? I mean, you're saying train tracks appear to converge, which I agree with in the distance, but they also appear to rise. Don't you agree?
Yes, everything on the floor
Yeah.
rises up. I'll give you eye level, but I
I'm not
don't think
trying
it's
to. I'm
exactly
not trying to
eye level.
catch you with the eye level. Let's, you know what I'm saying, and that's why I said towards eye level. And
Everything in the
appear.
sky goes down to the horizon. Everything on the ground goes up to the horizon. I'll give you that.
Okay, that shouldn't have been that hard. We both agree on perspective, right? That's basically perspective. You agree? That's what I'm saying perspective is. You agree with that, right?
Okay.
Okay, so once, and would that point of convergence, would that be the vanishing point?
Yes.
Would that also be the horizon?
Yes.
Now, put an object on the train track or on the water. So a cart or a train on the track or a boat, on the water. And it gets to that point. Like it starts at below you, at your feet, basically, if you're standing on the train track or at the beach, and it goes away from you towards that point and appears to rise. Once it reaches that point and goes further, what does it appear to do?
It vanishes from the bottom up.
Why do you think that is?
Well, couple reasons. One is the angle is lesser on the bottom than on the top because you're looking down on it, so you can see more of the top than the bottom. Second thing is we talked about horizon, we talked about vanishing point. What's happening is object is meshing with the ground, with the horizon.
Well, let's stop right there with that first one. Is that angular resolution?
I'm not sure. I'm not. I don't know if that's the right term, but that's what I called it.
Okay, that's why I asked you because I don't know either. Okay, so your second one?
The physical object appears to blend into the horizon, into the ground. So, for example, a building would start blending would start shrinking to the ground, not because the Earth is bending, but because that's the way we see objects. The last thing we're going to see is the top of it.
Because of the angle, right?
Huh?
Because of the angle? Like, because you're
Well,
looking
see,
up
I don't
more,
want them to.
you're
I
getting
don't want
more
them to
information.
catch you. I want them to catch you because if you have a high mountain, let's say the mountain is I don't know, 3 miles high. Technically, that mountain is above your eye level, but it'll appear below your eye level when it vanishes into the horizon. It'll appear to be below your eye level. For example,
I
you
agree,
can.
but if there's a part of a mountain that's at your eye level and a part that's above your eye level, the part above your eye level, you're going to be able to make out even more because of the angle and the information that's being reflected back to your eyes. Do you agree with that? Like, I think we're both in the same, if you're looking up at something or
Yes,
down at
because
something,
the angle is greater on the top than on the bottom.
so it is, angle does have something to do with it, is all I was saying. I agree with you. I'm on the same page. So we have that. We can stop there because I think we gotta, like, we both agree, and you made two reasons why it would do that. Now as that object goes past that vanishing point, is obstructed bottom up, is that because of perspective or an effect of perspective? Does that make sense? Maybe that
Well,
question.
the object's actually there, okay, but it appears to vanish because of I mean, perspective is probably the wrong word because it meshes into the horizon. Um, it's our optic. It's our optics. It's our optical resolution has diminished to the point where we can no longer make out the object, and it blends with the ground beneath it.
I agree with that also. But I would say perspective is a cause of that because perspective is why the water appeared to rise up in the first place. We know the water isn't rising up. It's just how our brain is interpreting the information as we look out over distance. So as that boat goes past the vanishing point or horizon, it's actually maintaining its actual position, but perspective is making the water appear higher, therefore obstruction is the way I see it. Do you agree with any or all of those points I made?
I don't know about the perspective because perspective to me is your height, is your observer point. For example, if you looked at a distant object and it started to vanish in the horizon, what you can do is you can go up higher. Now you're raising your perspective, and now you can see the object again, or you can see it better because now you have a greater angle.
Yeah, but I'm talking about everything remaining the same. Perspective is the floor and the ground and the walls or the angle that you see outward converge into a point. That's perspective. Now you can change one of those factors, your height, your angle or whatever.
I think perspective is maybe I'm using the colloquial definition is where you are, not what you see. In other words,
Okay,
if you're in a forest, hang on. If you're in a
I'm fine
forest,
with that.
if you're in a forest and there's a forest fire, if you're below the trees, you can't see this forest fire because it's in the distance, right? But if you raise your perspective up above the trees, then you see a smoke plume. That smoke is where the fire is. Now I raised my perspective. Now I can see the fire.
Okay.
That's how I think perspective is. Perspective isn't what you're looking at; it's where you are.
Yeah, no, I get it. But okay, so I'll ask you what you see in the distance, the water appearing to rise up or the train tracks appearing to converge. What do you call that if not perspective?
That's not perspective. That's
Okay, that's what I'm asking. What do you call that?
I don't know. We got to decide on a word for it. I know people in the discussion have word for it.
I'm confused. I thought you
That's
said
not,
that was perspective earlier. Did I miss it? I'm not trying to hem you up.
it's
I thought
because
that
of
was perspective all this time.
it's because of perspective that we see it that way.
Okay.
But that's not perspective. What you're looking at is not perspective. Perspective is where you are looking at the object. It's not the object happening. If you want
Well,
to,
that's what
we
we're
want to
seeing.
have a word that describes what's the train tracks are converging, and the street lights are converging to the ground, and the
Okay.
distant objects are meshing into the ground. The boats are meshing into the horizon, into the water. I don't know what the word for that is.
Okay, fair enough. But we do agree that once that object, boat in this case, goes beyond the vanishing point, it's going to appear most under most conditions to get obstructed or get, I don't even say obstructed anymore. It gets distorted, right, where the information is not getting back to your eyes, so it's just blending in with the ground. So
It
you're
blends.
not seeing the bottom of the boat because of that
It
blending.
blends. It blends into the ground.
Yeah, I agree with you.
And if you get a P900, for example, you take what those objects had blended into the ground by your eye sight. Now you can see those objects again with a P900.
Would you call
And
that an optical illusion because it's not reality?
you can call it optical illusion, but it's not really a good definition. An optical illusion is when a boat is floating in the air. It appears to float in the air. That's an optical illusion. An optical illusion is when you have a Fata Morgana and everything's upside down. That's an illusion.
Uh-huh.
When you want to see train tracks mesh and streetlights mesh and boats mesh, that's not an illusion. That's that's more like it is an illusion by definition, but that's
Well,
not
you
an.
just said it
You
was.
want to say it's an illusion.
Okay.
You want to say something like it's your resolution has diminished to the point where you can't see it anymore.
Well, no, if it fits the definition of an illusion, that's what you can call it. I'll read out. I just looked it up.
When you say illusion, I think like
hang
David
on,
Copperfield,
give me one
David
second.
Blaine.
Yeah, I understand you can perceive it as one thing, but I'm going by definitions. Optical illusion. Within visual perception, which is what I think we're talking about, an optical illusion is an illusion caused by the visual system, which I also think we're talking about, and characterized by a visual percept, and I can't read it, appears to be different from reality. Anything that appears to be different from reality because of how you perceive it through what you're looking through or your eyeballs or whatever, I think is an optical illusion by that definition. That's
Well,
why I say that.
what about the word mirage? You know, the Glober.
Yeah, that's a
Glober,
mirage. I'll give you that
Glober said
definition.
what you're seeing is a mirage, right?
Right. I know that definition by heart. A mirage definition. An optical illusion caused by the atmospheric conditions. That's what a mirage is. Now, there's different categories of mirages, ones that are up here upside down and blah, blah, Fata Morgana, blah, blah, blah.
Okay. An optical illusion happening from the condition. That's more like the mirage is a better word for me because that exactly explains what's happening.
Well, a
Without
mirage is an
being
optical
harmonized.
illusion. You can call it a mirage. I do as well. I call perspective basically an optical illusion or a mirage because it's not actual. It's not reality. It's something our brain's interpreting from how the information we're getting from how we see, but it's not reality. That water is not at that height, or that boat is not floating in the air, or whatever. The train tracks are not converging.
Mm.
Let me jump in.
Well, hang
That's
on.
got it.
The train tracks appear to converge. They appear to
Right,
converge.
but it's not reality. It's an optical illusion caused by the way we see.
I just don't like the word illusion.
Yeah, that's
You
a
don't
great
have to
point.
like it.
Hey, is my mic working?
Yeah, go ahead.
Yeah, what's up, man? Talk to
That's
us.
a great point, Rakia. Everything we see is an illusion. Nothing is its actual measurement, its actual position. That's fucking really true, man. You got to come to terms with that, right?
But by definition, right, optical illusions are not reality. And when you see something, a boat floating in the sky, you know boats don't float in the sky. When you see a boat that appears underwater, but it's not sinking, right? It's not filling up with water and sinking below the water, then you know that's not reality. It's an optical illusion. It's a mirage.
I got my own funny way of explaining it. I appreciate you guys' definitions of this because it's pretty much our job to like nail it down, right? I consider it like the position, like, okay, so you have an image. Every position on that image is subject to change due to atmospheric conditions. And yeah, lots of things can be happening between an observer and the apparent position of the horizon. Like it could be miles, tens of miles. And just acting like the only density gradient to take into account is the vertical one. Well, that's kind of crazy.
No, they try and put you into that position where temperature is the only thing because they know they're smart enough. You're dealing with smart people, right? So how can they not know the other things that cause it, right? You're saying they're only smart with the temperature? No, that's where most of the the easy research has been done, and you can easily do that with temperature gradient. You can easily replicate that, so people use it a lot, but that is nowhere near the only thing that affects how we see over distance. I mean, you got the mixing of many gases. Heat plays a part in that, of course, how fast they're mixing. It's called turbulence, basically. And if you're looking long distance over any type of disturbance like that, or air movement or gas movement, or which is the same thing, mixing it with humidity and moisture, like evaporation or some mist that's being blown up in the air by the wind, you're going to get some huge discrepancies in how you see on that day than when you have a clear, calm day that doesn't have a lot of those disturbances. That's why they only talk about temperature, because in all their low level, long distance observations over the marine layer, especially when they're showing like a building underwater, which, oh, by the way, fits the description of optical illusion, because buildings aren't below water generally, right? Then there you go. You have to figure out what's causing it. So when you look out over that distance and you know that the marine layer is usually turbulent, then there's your answer. Throw in perspective, throw in, all that other stuff, everything else, the angle of the light source, which is usually the sun. You throw in everything else and you got yourself a cute little mirage almost every time you look out over distance. I mean, very seldom can you look long distance, I'm talking about over 3 miles, and not have some type of mirage or distortion or optical illusion, whatever you want to call it, happening.
Yeah, complicated calculations can come into play. Like how much is the oh man, I can't even say what I'm thinking. But because the ground is rising to your eye level, and the further you look, there's going to be more distance between the position below your eye level and your eye level. So the amount of like the density gradient in that position is like fucking. How can you even measure that?
You
You would
can't.
have to, yeah, you can't. You would have to
It's,
estimate like every distance between every gradient, and it's just ridiculous.
you can get
And that's why,
percentage
let me
average.
respond to that. And that's
Mhm.
why I call bullshit on Walter Business Calculator, because they try to have a box for refraction, but you don't know what the refraction is because nature gives you refraction. You couldn't know what the actual refraction is to put it in a box to get a result, to get a real result confirmed in reality. They're just playing with numbers and they're making up shit.
They averaged out their refractive effects to match a radius. Now, if that isn't wizardry or magic, I don't know what is.
No, because you have differences in temperature and differences in density over miles. And if you use that, if you measured let's say I had a 10-mile observation, you have to measure every mile of that gradient, and what you'll get is a difference in density and temperature, et cetera. So it wouldn't give you a conclusive result. You can't just put in a number in a box.
Yeah, the light is passing through a thicker layer. Like, how do we not account that? It's literally more volume. I don't know. It's just, they don't account for that. I talked to Jesse Gordon about it. He makes good points. But I don't know. He says there's no such thing as a front to back gradient, or like we don't have to take it into account. Like the volume of a container where light is passing through a certain medium. Like, what if you take that same container and make it pass through it again? Isn't the path gonna change? The answer is yes. But we don't take that into account when it comes to the atmosphere. We don't act like there's different large amounts of mediums that the light is passing through across the surface, as it goes towards the eye level.
Yeah, I'm with you, Electric. The reason why they can't have it back to front is because that would ruin their whole mathematical number. They think it's consistent, and there's no way it could be consistent over 10 miles.
I actually feel like I'm strawmanning the globe right now.
I don't think you can straw man a fictitious object, to be honest. Until you prove that water is curving, you can't have a globe. So when you talk about how you stand at the edge of a beach, telling me you're on a globe, and all that water should be falling away from my feet, yet it's rising towards my eye level in all directions. And then when you try and measure any body of static water, it doesn't curve. Yeah. Why would I ever believe you? Literally, the only measurement over bodies of water that try and show any elevation change or angle change are a half a mile or more. And they're not straight line segments of, extended over that body. They're a one shot, which can have all kind of issues, right? I mean, just a fraction off on the zenith, and you're getting a difference in change, elevation, especially over a half a mile. You can't teach me how light is affected over distance, especially low level over the marine layer, and act like an expert on that, and then go out and take an optic and try and measure long distance over the marine layer and say you're getting an accurate measurement because of how light is not refracting on that day. I mean, you just can't. I was born at night, but not last night type of thing. They try and act like experts on both fields, right? Teach us how temperature gradient has to be stable to get an accurate measurement, because that's when light is not bending at all. But then tell us how differences in pressure and dust refracts light. I mean, they hardly ever talk about refraction. I mean, diffraction. They always talk about refraction. But the scattering of light, I mean, there's all types of ways that optics are affected by the information that's getting into their lens.
I hear you.
What is diffraction, and is that an important word for the conversation?
I got you. The process by which a beam of light or a system of waves is spread out as a result of passing through a narrow aperture or across an edge, typically accompanied by interference. Okay, so it's talking about the light passing through an aperture or an edge. Hold on. Yeah, it's bending around an obstacle. Yeah, that's the definition of it.
But is that happening in our observations?
I mean, they can't prove that's what's causing the image, you know, because it's far away until you go there and then it's actually there and you say, oh, yeah, it was diffracting before. It's kind of silly. Yeah, like how do you prove the cause of where your image is appearing?
Well, you can. It is scalable to a degree. I think. I don't. I'm not saying that refraction and diffraction are not a thing. I'm just saying it could happen over a flat plane and give us the same effects. It's just different to the degree of what it's having to do. I mean, does light have to bend more or less to make an object appear above a sphere than on a flat plane? Less, right?
Yeah.
I mean, if an object on a flat plane is supposed to be this distance away, you know, and it appears to be higher, which would tell you it's further away, then it's probably being loomed up or whatever you want to call it, or magnified closer. Right? These things we know happen when things are magnified. That's what a zoom does. It just magnifies what the lens information is retaining and brings it closer, like filters it that point more where you're seeing just that, and then that makes it appear closer. Magnification. You can do the same thing with your eyes. You can squint and focus in on one thing right in front of you at your eye level, and you're going to be able to see that thing more clearly than if you just open your eyes and let all the light from all around you, you know, filter in.
Right on.
Or you can put your you can put your hands on either side of your eyes and block out all that information that's coming in from the side and focus in on what's in front of you, and you're going to be able to see more clearly. Some say further. I just say more clearly. You're always seeing what you see, right? Under the conditions that you're in. Take your hands away and you're going to see that object that's still at the same distance, but it's going to be appear less clear.
Yeah, I went ahead and tested it out. Held my hands up against this image, and for sure, man, feels like I'm resolving more pixels within that smaller space. Feels
Of
like it.
course.
Yeah.
Of course. That's all a camera lens is doing also when you zoom in. It's just filtering more of a specific point. That information, that light is getting to you more clear. It's magnifying it. Magnifying glass does the same thing. A point or towards a point.
All makes sense to me. I like to think I get it.
Yeah. You think you know what you're talking about until you get Zanuck and RC and like Moyak Man screaming in your ear for 6 hours trying to distort what you've already figured out.
Yeah, the word muddy comes to my mind sometimes. Feels like art gets muddied, yeah.
Muddy it, right? Make it unclear. Yep.
Yeah, I guess the claim is, in fact, that the fact that there is such thing as diffraction, which is, I guess, an image being spread out due to light bending around an obstructed, like an edge. And they're saying that, oh, the if you see really, really far, I guess you're seeing diffraction. Is that the claim? How come I've never heard the argument really put together like that? Like you're seeing a stretched out image because it's bending around the surface of the Earth. That can't be the claim, is it? I don't even like entertaining this anymore. I really don't. It should be obvious. I think it's important that we like make sure that we don't say that. I don't know. It's like a weird misspeak when you use the word perspective because things affect what you're seeing. Perspective it has an effect itself. So it's just like you automatically always have to combine the two. Like no matter where you think you're looking, you're never going to have some perfect condition where you're seeing the actual position of something. It just doesn't exist in nature. Because you have perspective affecting it, and then you have atmospheric conditions and lensing and everything else. The shape of your eyeball is going to affect it. The shape of everything is going to affect it. So I don't know. You can't say perspective is affecting of the. It's always going to happen.
I have a question for you guys. You still there? You still there, Rakia? Electric?
Yeah, can you hear me?
Yeah. Okay. So here's my question to you: how does seeing through a medium, the density being more dense on the bottom, greater on the bottom, how does that to get you to see around the curve exactly?
In my opinion, it wouldn't. But they have a refractive index and like all the positions on Earth, the temperature gradient, and how much the light is going to bend down. So they don't even have to do anything. Like that, they already did all the math. If it were bending at
No,
a certain
because I
rate,
drew a picture of like a bow, like I drew a picture of like a like a ball, and let's say you're on top of this ball, and this is just saw like a rainbow, right? If you're on one side of the rainbow and you're looking out across to the other side, um, if the density was greater on the bottom, you would you would end up looking at the ground. If light bended through a density through a medium, you would look at the ground, right? It couldn't get you anywhere around that curve, because you have to see at the same level. You have to see. You have to be looking at the same level. The density. If the density went down, you would never get around the curve. You know what I mean? So I don't see how that can get you to see around the curve. If the density was the same, for example, you would just see, straight. And that's how you have to see. You have to just see. You have to keep it the same density to see around the curve. And then they claim the light will go down into the deeper density, which would never get you around the curve. Am I right?
Wait, are you saying that the density shouldn't change for you to see around the curve?
Oh, hey, is that Bacon? What's up, Bacon?
What's up? Yeah, I'm
Yeah.
trying to understand your point.
How does a density greater at the bottom get you to see around the curve? It wouldn't. It wouldn't get you to see around the curve. You would just be looking at the ground eventually.
No. The thing is, light will bend towards the dent, right? So if the denser is below, then
According
it
to
would bend
you,
down.
light bends towards the denser medium. So you can
Yes, that's what I'm saying.
how did that get you to see around the curve?
Yeah, I was trying to explain it. So yeah, so it bends
Can
toward the
you draw
denser.
it? Can you draw a picture for me?
Sure.
Because
I'll stream
I drew a
my
picture,
screen.
and
What
I
about
don't
that?
see how that would work for you.
I'll share my stream. So sorry, I'll share my screen if that's okay.
Yo, Bacon.
Yeah,
Yo.
thanks.
Okay, so let me make a curve here. And I'll create a gradient now. Just give me a second.
I'm also going to send you a video, Godric.
Thank you. And my DMs are in the live stream.
Put it in the live stream.
I'll create a gradient with only 3 layers because it doesn't take me forever to do it. But I think it would be enough to explain what the idea is. All right, can you see that?
Yes, go.
Right. Okay, so yeah, if there is no gradient, let's start with a simple thing. So no gradient, there is a person here, and there is whatever here. Say a building, right? The person can see all the way up to here. You can't see what's below here because the surface is in the way. So the light that is reflecting from down here below can't reach the observer. It can only go all
Do you have
towards.
Do you have to assume? Do you have to assume it's a ball?
I thought you wanted to know how downward refraction can make light go around the curve. So that's
Okay,
the
go ahead.
curve,
In that case, go ahead. Yeah, thank you. Go ahead.
right? So if the observer can only see only from here up, you realize that from any point here on, from any point above this point, you can always connect the building to the observer's face, but not here below. It will go through the surface. So there's no way light can go from this part of the building towards the observer, so he can see it. But now let's introduce a gradient, right? So I only added 3 layers on this gradient, so it's easier to explain. So the light is always reflecting towards all directions. So you have light refracting that direction, in that direction, in that direction, in all possible directions. But what we want to know is how can the light get from this building to the observer in different points, right? So the light that is leaving the building, let's say in this direction, when it reaches this point here, it's now entering a less dense medium. So instead of bending towards the medium, it's going to bend away from the medium. So it's going to deflect in this direction slightly. And as it reaches this layer, it's going to deflect even more in this direction. So as you can see, it's curving towards the observer. So if all the light that it leaves the building curves towards the observer, which is downwards, then the light that is coming out of this part of the building, instead of going straight, can curve and reach the observer. Does that make sense? Like as it
Okay,
goes.
can you do that? Can you do that on a flat plane now?
Sure. Yeah, I can make a easier gradient on the flat plane. Okay. Okay, so what about it? What do you want to know on a flat plane? What happens to the building? That's what I want to know.
Show it to us curving on a flat plane.
The light?
Do the same thing you did on your globe and make it on a flat plane.
Well, I was explaining how it goes around an obstruction. There is no obstruction here, so what exactly you want me to do?
Bacon, please do exactly the same thing you did on a flat plane, please.
Yeah, what I did was to show how it goes around an obstruction. There is no obstruction here. So what exactly do you want me to do?
Show me how the light would act
Right.
on a flat plane.
Okay, so if the light is going that direction, for example, it's reaching less and less dense layers, so it would be deflecting in this direction, and it would bend down. So all the light here is bending down. Let's make it like this. Let's use the bottom of the building. So the bottom of the building no longer reaches the observer in a straight line. It doesn't come from this direction anymore. In order for the bottom of the building to reach the observer, because it's bending down, it has to come from the light that is being reflected in this direction. So it will bend down and then reach the observer. So now the observer sees the bottom of the building in this direction instead of this direction, where you would see if there was no refraction. So the building is going to look like it's like here.
Okay,
Because-
but Bacon, didn't you just explain how we can see distant objects on a flat plane?
No, this is showing that the building is going to look higher.
If the building looks higher, that means that the light coming from the observer is bending towards the less dense medium.
There's no light coming from the observer.
We don't see through light. There's no light wave from our eyes to the building.
No, the light goes from the building to your eyes, right?
Bacon, if I send you a video, will you play it live right now?
Sure.
It's only 1 minute.
Yeah.
Thank you, Bacon, but I don't see your point. If the density, if the gradient is more dense on the bottom and the light bends towards the gradient, it would move towards the ground.
Yes.
It
The
wouldn't
light that is
stay
going
in-
straight. The light.
Listen. It wouldn't stay in the same place. It would bend towards the ground because you claim that it's denser at the ground, so light will bend to the ground. It's not doing that. In the first
is.
example, your light is staying at eye level,
No, you're not getting it.
not bending towards the ground.
There's one thing I mentioned in the very beginning is that the building reflects light in all directions. So this point of the building here is reflecting that direction, that direction, that direction, that direction, all directions, right?
I don't know why that would be meaningful that you said
Yeah,
that.
if you let me go on, you might get what that's meaningful. So the light that is going that direction, straight forward, is gonna bend down and reach the ground, and the observer is not gonna catch it, right? So he doesn't get the light that is leaving this point in this direction, but he can see this point from the light that goes in that direction, because that direction is gonna bend down and then reach the observer. So, and he sees that even higher than the bottom. So he can still see all the points of the building, but they come from a higher direction. You're right. The light that leaves the building reaches the ground because light's bending downwards.
All right.
But
Bacon.
the light that is reaching, let me just finish the explanation together. So the light that is reaching the ground is not being captured by the observer. So we don't draw those lines because they don't help we understand what the observer is seeing. But you're right, that light does reach the ground. But because it doesn't reflect only that direction, it reflects in all directions. There's still light that can reach the observer. The difference is it comes in a higher angle. That's why you see things higher when the density is in the bottom.
Okay, so on the flat plane, you're saying we see things higher than they actually are.
In both surfaces, in both the curved and the flat surface, if the light is bending down.
I'm gonna try to make the point. I'm trying to make it real simple and easy. On your globe example, what you showed us, the light is not bending down. You showed us the light is staying at the same eye level. You showed us that. It was staying in the same. It was staying in the same medium. It wasn't going to a lower medium.
Well, it does. That's still bending down, because if it wasn't bending down, if it was only going straight, it would not hit the observer. It doesn't go straight, so it bends. Does it bend towards the surface or away from the surface? In the drawing of the curved surface, it bends towards the surface. That's what we call down.
No, but you had it staying in the same eye level, on the same level.
Correct.
That's not bending.
That's still down. It is, because if it was going straight, you wouldn't curve towards the observer. It would shoot up to the sky. That would be the straight path. Okay. I have to draw that again.
When it eventually hit the ground or no?
That depends in which direction it is leaving. Some of the light is going to reach the ground, some is going to reach the observer, and some is not going to reach neither the ground or the observer.
Do you know why that doesn't make sense, Bacon?
Why?
Because when I see a building, I see it in one place. I don't see it higher, lower, and in the middle. I see it in one place. So how can you say light?
You see where you see it. You don't know if.
Hang on. How can you say light hits the ground and light goes up also? How can you say that if I'm seeing the building in one place?
The light that reaches the ground you don't see. It reaches the ground.
Let
me respond to you. Whenever you ask a question, you gotta right. You see the light that reaches your eye. That's the thing you see. If it doesn't reach your eye, you don't see it. That's how light works, how your vision works, right? Don't have your eye spread around the ground. You have your eye inside your head. And that's the light you can see. It's the one that reaches your eye. So yeah, you're going to see one building, and you're going to see the building where the light can come from to reach your eye. And you can say, well, you see one building, therefore its position is not being affected by refraction. Well, that's not true. That doesn't imply that. But yeah, go ahead. What were you saying?
Bacon.
Bacon, I got part of what you're saying. Thank you for that. But I wasn't convinced. So we can continue on that later.
Okay.
Go ahead and play the video.
I sent you a video. I can check your messages.
Sure. It's open. I was just waiting for this conversation to end. So, okay, I'll share now. No, let me just open that in another tab. This one, right? Nope.
Yeah, play the video. Oh, you ain't got no volume.
Is somebody trying to talk to me in voice chat?
Can you start the video over with the volume?
Sorry? What did you say?
There's no volume.
What do you
Start the
mean?
video over with the volume, please.
I already put the volume. You can't
There's
hear
no
that?
volume. There's no volume, Bacon.
Well, there is for me. I don't know how to fix that. I think that's because maybe that's a Linux thing. This is my computer work, by the way. Sorry,
It's
my
when
work
on
computer.
Discord, when you go to share your screen, I think you have the ability to like share your Firefox window like right now.
Yeah, I'm sharing the window. Yeah.
Yeah, but when you started your stream, I think you were sharing your whole screen.
You want me to reset the live stream?
Yeah, try when you go to start the stream, see if you can make it so your start is. See, now it's getting complicated. We could all just watch the video. It's 1 minute long.
Fair enough.
Just post it in the general.
Oh, I can't say what the guy's saying if prefer that, but I think I think I already had this problem before. I think this, like the Linux version that I'm using, doesn't work sharing sound. I can try to go to my other computer. Just give me a second. I'll be right back. Hey,
Yo,
yo, I'm back. I think it will work. Ever never had any problem.
all right, let's try again.
My other, yeah. Just give me a sec. Okay, see if that works now.
Oh yeah, nice and loud.
Okay.
Thanks so much, Bacon.
Okay, so what's up with the video?
What I want to say is that is all not proven. That's my point.
Okay.
Yeah, like the position, like where we're seeing the sun, that's the theory for the globe model right there. That the position of it is refracting the closer it gets to the surface of the earth from our perspective. And I'm claiming that the sun is just above a plane and that it's just converging at your vanishing point the farther away it gets. But it's still an astronomical object, still pretty far away.
All right. And what do you think is the path of the sun? Like, what? How would you describe the
I could post a
path?
picture right now.
Okay. But that's, I mean, then I have to mention that perspective thing again. Like, the sun is a close object,
The sun would
and
have to
as
be following some like path of like a magnetic field line or something.
uh, you're posting something somewhere.
It's all loading. Oh, the first
Okay.
GIF is 34 megabytes. It's just putting the idea of like the cause of analemmas, the cause of seasons. Like, I really think the path of the sun is being dictated along some kind of lines of a magnetic toroidal field, something.
Well,
Nice toroidal
I'm
you
not
got
sure.
there.
I'm not sure how that answers like the path of the sun because I see a bunch of lines changing. I
Yeah,
don't
I
understand
know. Yeah, it
what's the
is a
path
bunch
of the
of
sun
lines.
there. Yeah, but do you have one in which the sun is moving? So I can understand
Yeah,
how
let
do
me
you
try
think
to
the sun
find some.
moves. Okay.
You got to imagine the analemma too.
Uh, right.
I've yet to see a perfect example of what I'm looking for, but that was sitting right at the top of all my in my folder. So there you go.
Well, the reason why I'm asking that
Yeah.
is because if you think the Earth is making a circular path, uh, then how could we see it like rising due east and then setting due west?
No, no. Okay, so that circle that's not the model. Okay, that's just supposed to
Okay,
show how there's a projection above us that's making the sun. That's supposed to explain eclipses. Is it's a projection onto something above us,
I'm not sure
and
if I understand what that means.
path that light is on is being caused by something magnetic.
Well, regardless on the cause of it, well, I just want to understand where the sun is and how it moves. Like, what's the path it makes,
I can't speak for
regardless
those
on what the
people,
cause
but
is.
I'll tell you that. And right now, my position is I guess I'm on the fence on where the sun really is still, but I think that it's being projected onto some kind of layer of the firmament that is a super solid, like, you know, really, really cold helium that is a super solid now.
Okay.
And whatever is being ignited, and yeah, I think it's like that's why we think it's hydrogen and helium exploding or whatever, is because whatever's pointing at the firmament is creating the sun. It's hard to put into words what I think of.
Oh, anyway, like the thing is, if you want to attribute the position of the sun to the sun being local and moving away from you, I mean, you should at least get smaller.
Um, no, I don't think it. What is that sweet spot in your perspective where, like, you know, mountains don't appear to get smaller at a point? You know what I mean?
Yeah, because the distance isn't changing that much because it's already very far. Like
Yeah,
if
that
you
happens
change,
to astronomical sized objects too.
sorry.
Same thing happens to the objects we see in the sky. They don't change size because of how far they are.
No, but if that's the case, it would also not change direction because the change, the amount it changes in size is also the amount it changes in direction as you move away from it, or
Changing its
as you move.
direction is perspective.
No,
It's
perspective doesn't change
convergence.
direction.
Well, I believe the path of
Perspective,
the sun is following the path of, like, you know, convergence in our perspective. That's what I think.
okay, let me try to. If you think the sun is above you and some hours later is at your horizon, it can't be too far. The further it is, the less the angle would change. So if the sun is, let's say,
We don't even have objects this big.
4,000 miles,
Like, how do
well,
we know that objects this big do this? We don't have any good examples, do we?
I'm talking about, oh, perspective doesn't care about this, like the scale. It doesn't change with scale. If you scale some things up, they look the same from according to perspective. If you scale everything by the same amount, what matters is the proportions. So yeah, some might be very very far. If it's too far, it's so far that it doesn't change angular size, then everyone would see the sun in the same direction. Because the further it is, the less parallax there is. So if we are all below a flat surface and the sun is too far from us, we all would see the sun in the same direction, or more or less the same direction. And you know that's not the case. It can be overhead to me and in your horizon. The sun would have to be very close for that. It can't be a lot further than some a
You
couple
just said
thousand
it.
miles.
You heard that? Dude, you literally just said the flat earth model. That's what it is.
Yeah, that's what I'm saying. That's
Yeah.
what I'm saying. There's have a problem because it can't
Hold
be
on.
too
Bacon,
far.
do you mind? I don't like doing this to people, but sometimes I feel like I really value what people say and I clip the recording. Like, I have to clip what you just said.
Okay, what's the thing I said you think should be recorded? Yeah, well, I'm talking. I'm
You just
saying.
broke down very well how whatever you just said, it was that was it. That in my opinion, that's how my model works. Hold on.
Bacon.
Yeah, and I'm trying to get to why that's a problem.
Bacon.
Okay, go ahead.
Cool dog.
Thank you.
Do you know who I am?
No.
Maybe you'll figure it out someday.
Okay. As I was saying,
Ask around. Maybe you might figure out who I am.
I'm not that curious.
My account got nuked.
Okay.
Yep.
All right.
Yeah, I was also
So
in 24/7 Tartaria and I got permanently muted in there for talking to you.
talking to me?
Yeah, talking to you on your Cool Dog account.
My Cool Dog account? I don't have another account.
No. You just said you were Cool Dog.
I don't know what that means.
Yeah, to me you you sound like Cool Dog. I know it's you, dude. You don't have to hide.
Oh, you think I'm a guy called Cool Dog?
Yeah.
Okay.
Mhm.
Yeah, I'm Cool Dog then.
Yes, you absolutely are.
Does he also have a Brazilian accent? Is he also Brazilian?
No, actually, Jewish.
Uh, so you think I'm Jewish? Oh,
Mm,
Jewish is I mean, Jewish can be Brazilian, right?
I, I'm not saying you're 100% this person. I'm just saying it sounded like you were.
Oh, I thought you said you knew I was.
Well, I have a hunch.
Right. Does that person speak Portuguese?
Probably not, but he could speak multiple
Right,
languages.
I do. I only
He
speak
he
Portuguese and English.
he lives in Israel.
Yeah. The only person I know who lives in Israel is Chaiki. And he doesn't
Is who?
sound like me at all. Chaiki.
I've never met him.
Well, anyway, I'm on these servers for around 2 years. Everyone knows me here. Everyone
That's
knows I'm
cool.
Brazilian. And I can speak Portuguese too. If that's not enough for you, then I guess I have to be this cool dog guy.
Yeah, you should definitely meet him. I'm not friends with him or nothing, but he's been in other flat Earth servers as well, even though he's not a flat earther. Cool Dog is his name. Got a dog with glasses on it. You'll probably see him around sometime.
I don't recall that, actually.
Dude, you sound exactly like him. I'm not even capping.
There's no cool dog in Tartaria. So the Tartaria server.
Which Tartaria server? 24/7 or Cosmology Tartaria?
Cosmology. Is there another one?
Dude, yeah.
Is that an active server?
I'm sorry?
Is that server active? Do people still join there?
Which one are you talking about?
The 24/7 one.
Yeah, even though it keeps getting nuked.
Right. Can you let me there then?
It's because people are reporting it left and right because of the mod abuse.
Oh, that never mind. Forget the invite.
You got like a million different mods in there.
Okay.
So Bacon, what I wanted to clip something that you said, it was very significant to me. I freaked out and I was like, oh my God, he said it. It was due to the proportion of the size, right, of an object and how far it is, its position is going to change less on a flat plane. But the sun is moving on a flat Earth.
Okay.
We're not spinning to see the sun. So when we see the sun moving across the sky, it's because the sun is moving across the plane, the stationary Earth, and
Yeah, I understand that,
lowers due
but
to perspective.
yeah, I understand
That
that.
can happen
But
to something really big. We see that when we're anyway.
okay, but if it lowers due to perspective, then it can't be too far. If it's not too far, then it should get smaller as it get away from it.
I feel like that's what we see, but it also gets closer to our eye level.
So we don't see it getting smaller. It has, it's like half a degree
The
big
sun changes all through.
all the time. Yeah, but it changes slightly around half a degree. Think about, okay, so let's say there's a building, right? And the building is as high as the sun is. We don't know how high that is, but the building is as high as the sun is. So if you're right in front of the building, your nose is like touching the wall of the building. If you want to see the top of it, you have to look straight up to see the top of the building because you're right in front of it. As you go away from the building, the top of the building starts to drop, right? So far so good, right? And as you keep getting further and further, the top of the building keeps getting lower and lower. But the size of the building, it will appear to shrink by the same amount because the size is basically how far the top is from the bottom, right? So if the top is going down, then the whole building is appearing smaller and smaller. So its windows. Its windows are going to also proportionally look smaller. If the building looks as half as big as it used to look, the windows are also going to look half as big as they were before. So everything gets smaller within the building for the top to drop. So if you put the sun on top of the building, and as you go away from the building, top lowers and lowers and lowers, the building gets smaller and smaller and smaller. The sun would be also proportionally smaller because that getting smaller thing is going to be applied to both the sun and the building. Why would the building get smaller but not the sun? Why the sun only lowers in position but still looks the same size? You know what I'm saying? That's the problem I'm trying to point out.
What I want to say is like I gotta reach to tell you my my idea. But like I said, man, it's always projecting onto a firmament.
Well, I'm not sure what that means.
The sun is where the
Did you stop saying so, or did you cut off? I don't know. You're saying
Oh,
something
you said you
fancy,
don't know what I mean. I'm just like I don't know how to put it plainer.
right? Yeah, that's the relevance of modeling things. Then the model speaks for itself, and you can compare the model to reality. So if you model the way you think is going on, and the sun does something different in your model than we see on reality, then that falsifies the model, right? If it does the same thing in your model as it does in reality, that shows your model is consistent. If you try to model a closed sun and make it lower with distance, that doesn't match what we see. The sun always gets smaller when you do that in actual models, and we don't see that. Also, the sun doesn't drop in a constant rate. It slows down after like 30 something degrees. It's noticeably it would be noticeably slower according to perspective, and it will keep getting slower. And if the sun
What are
is
you
at
saying would
constant,
keep getting slower?
how much the sun is lowering the sky, so it will lower less and less. That's what you get from perspective. If you have a local sun on a flat Earth, it just goes away from you.
On a flat Earth, it depends on where you are on Earth too.
Correct. But what matters essentially is your distance to the ground position of the sun and how far the sun is from that ground position. So you can get a triangle and you can solve for how high the sun looks like. That's all that matters, at least from a perspective point of view. And that gives you a drop of the sun that keeps slowing down much more than we observe. Like the change in speed of the sun that we observe is very slight. It doesn't match perspective. Doesn't matter how high you put the sun.
Hey, you just said it though. The closer the sun gets to the horizon, the rate of declination changes.
That is the same thing, what you just said. The sun getting closer to the horizon is what the change in declination means. It's the same thing. Saying the declination is changing.
Yeah, and I'm saying the cause is perspective because it's not 500,000 miles away. That's what I'm saying.
Well, what I'm saying is perspective gives you a specific rate of drop for the sun, and it's not the one that we observe.
Yeah, it's proportional to the distance.
No, it's not. Not according to perspective.
How do you even test this though? Like we need like gigantic fucking mountains and things to even know the
No.
proportion.
Well, but it doesn't matter because you can play with how far the sun is and see what would be the prediction for perspective. And it makes I can show you that. I created like an interactive diagram in which you can see how much the angle would change depending on how far the sun is and what is the observed rate. And then you can try to put the sun in some height that matches the observed rate, and you just can't.
Right, and there's days you could look at the sun, and there's days that like it appears big, and the closer it gets to the horizon, it changes colors. So the horizon, to me, I don't want to say it changes angular size, but like it's apparent, like rate of declination definitely changes.
Sure.
And you're
But
gonna
it
say right
changes.
off the bat that these are the only objects that aren't affected by perspective.
No.
Like the model that you put forth says that they're so far away that they don't. The rate of declination towards the eye level isn't changing because of perspective. It's changing because of what? Atmosphere?
No, because your orientations change. So each person, if there are many people spread around a globe, each one of them has a different orientation. So the person that is right between the sun and the earth has the sun overhead. The person that is a quarter of the circumference away from that one, you have the sun at their horizon, because they're tilted 90 degrees compared to the one that has the sun overhead. So what the difference between those two people is their orientation.
Yeah, on a flat Earth, your GP is gonna affect these objects, like how much they. Yeah, dude, like you get it. You hear me?
Mm-hmm.
Same thing will happen on a flat Earth.
No, because on a flat Earth, everyone has the same orientation. So the angle would have to change to perspective.
How big are you
And
making the sun?
why does that matter? Because when we talk about the position of the sun, we talk about its middle point, right? The center. And if you make it bigger or smaller, the center is in the same place. So it doesn't really matter what's the actual size of the sun.
That's not true. I think it really matters how big you make the sun on a flat Earth model.
Well, but if like all we were talking about is the position of its center. So making it bigger or smaller doesn't affect where the center is, right? So you wouldn't make any difference for what we're talking about. How would it? Like we're just talking about its
Exactly what we
position.
see.
Well, I mean, we're not talking about size at this point, only at its position. So we don't have to have a size to talk about its position. Those are independent, right?
I don't want to like try to make a different point right now. Hold on. Bacon, how many times have
Wait,
we this?
I gotta make a phone call. Just give me a second. Be right back.
Ugh. This silly thought is bouncing around my head. In the strawman flat Earth model, like the A.E. Gleason's map, where the sun is just like rotating around the North Pole over and over again in a really short path, I feel like that's a strawman map, and the sun's path goes like way too far. Yeah, I think it goes like, I don't know, not in that tiny little tight circle.
I'm back.
Yeah, I was just mentioning that whatever path the sun is on, that A. Gleason's map, and you imagine the sun is just, wrapped around the North Pole. And that's why, like, I don't think that's the true path of the sun right there.
Okay. Yeah, well, I need a true path of the sun to evaluate if it's consistent. This is why we keep asking for a flat Earth model.
Oh, you gotta map the sky, dude.
Hey, do you think the 16 nautical miles per degree is true? Do you think that relationship is true?
Yeah.
Why?
I think it's not.
I said it is true.
Why do you think that's true?
What? It is true.
Yeah, I believe that too. But I want to know why you think that.
Because the positions of the stars in the firmament rotate, and I don't think we have it entirely mapped out how wide that firmament is and where that rotation, like I guess the edge of the circle is. Like we think it's like at the Antarctic. Like we picture a celestial sphere and it ends around the globe. Like at the Antarctic or the Arctic or something. It's weird. We just don't have it mapped out. I can show you a bunch of pictures of like how they make their celestial sphere. Like I think you understand this already. You got to actually get the positions of the stars, where they are in the sky, where they are above the land, not just the GP of the star. And then that'll tell you the positions of the stars in the sky, and that'll tell you the actual rotation of the sky. And I'm telling you, that's going to go way beyond the Antarctic, if you ask me. I don't think the stars are just like tightly wrapped around like the edge of the Antarctic or something on the A.E. Gleason's map. It's like a million strong to deal with.
Okay, I don't know how to get the 16 nautical miles per degree out of what you said. Like, because when I ask why I believe that, I mean, like, what do you think justifies the 6 nautical miles per degree?
The laws of perspective and the effects of the atmosphere. And if the position of the firmament is actually moving, like where the stars are, if that's moving rather than you spinning and the positions of the stars apparently moving away while you're on a rotating surface, it's just the opposite.
How does that give you 6 nautical miles per degree? How do you arrive to 6 nautical miles per degree from what you just said?
Because that rate of declination is due to perspective.
The rate of declination of perspective is will always be 6 nautical miles per degree. Why? Where does that come from?
Yeah, I can like pull up a picture. Like if you have the firmament as a dome, then the positions of the stars, how they're affected in your perspective is going to change.
Not really.
Sure, they're going to change. Well, they will change, but like at what rate? Why 60 nautical miles per degree? Where does that come from?
Just imagine
Like,
if the GP of a star, like if I go to that location, then that means that if it's actually positioned like locally above that person's zenith, then it's gonna change in my perspective the closer I get to it. Like it's gonna
yeah,
appear in my zenith eventually because I'm getting
right.
close to the star.
I agree. I agree. The position changes. I agree that if you're below it, you're going to see it
Yeah,
over
like
there.
literally, like every GP of the star, like that's literally where the star is. It's not like bazillions of light years away.
Okay. Yeah. Let's say that's the case. Now, why do I have to walk away from it 60 nautical miles for it to drop 1 degree? Why
Because
not 70 miles or 70 degrees?
there's a firmament. Because it's like the shape of the firmament, I guess, is spherical.
Yeah, but why? Where
It's a,
did the
it's a celestial
60 come
sphere,
from?
literally. I feel like it really is. Whatever's rotating, it is in a spherical path.
Well, I'm not sure if you understand the question. Like, I'm saying, how can we get to this number of 60 nautical miles? Why this is the distance you have to travel? Why not 62 or 50? Why is it exactly 60 nautical miles? Like, how do we get this number from what you said?
What are you asking me?
I'm asking how the things you said.
I mean, I feel like you already know the answer. You want to just tell me what you're thinking?
No, I don't know the answer. I mean, I don't see how we could get the 6 nautical miles
I
per
said
degree
that
from what you said.
the amount of declination or the rate of declination you see, the farther you get from a star, is because of your perspective. It's like the farther you get from an object is going to get closer to your eye level, and that's apparently what we see. And
Right.
even better, it actually slows down the closer you get to your eye level, just like everything else in your perspective.
Okay, but that still doesn't tell me that the number would be 6 nautical miles per degree, right? What you're saying is to explain how.
Gotta invoke a sphere, a celestial sphere like this. Firmament is in the shape of a dome. That's what I believe.
Oh yeah. Okay, so how do I get from a dome-shaped firmament to 6 nautical miles? Why the values? How do you get to the value of 6 nautical miles? I mean, you said the sky isn't entirely mapped. I'm not sure if you know the size of the dome, how far it is. I think you would be agnostic on that.
Of
So
course
if
I
you
know.
don't know,
That's what I want to figure out. I want to know the positions of the stars. I don't know the
I,
size of the dome. I think it goes beyond what they claim would be circling on a Gleason's map. Like I said, I think it's bigger than that.
sure. So I mean, if you don't know like none of that information, then how could you arrive to the 6 nautical miles per degree without any of those values? Like I don't know how far it is, how big it is, how they're mapped, but still you still think there
Yeah,
is a
it is.
6
I'm in
nautical miles per
square
degree?
one. You want me to literally map the sky? I will try.
No,
I
I'm not
devote
asking that.
to this.
But if you're in square one, you shouldn't accept assumptions like 6 nautical miles per degree, right? Until you know they're true.
Every star used for navigation has a GP also, so they can't be beyond the wall or beyond where we go. On
Did
the,
you did you say we shouldn't accept assumptions?
Yeah,
I would.
some assumptions. Yeah, like if the 6 nautical miles per degree is an assumption used in celestial navigation.
No, it's reality. I feel like.
Yeah, if you think so, that's what
Yeah,
I'm
you
asking.
could just
Why?
make a
How do you?
completely
Why do you think
other
that's right?
proper assumption. It's not like it's 100% only can work on a sphere. That's not the truth.
Well, I think I have enough evidence that it can only work on the sphere. The 6 nautical miles per degree can only work on the sphere.
yeah, I challenge anybody to actually work it backwards on a flat earth. They can actually work.
Yeah, I know. There's that would take a minute. I mean, I do want to try. I don't have Blender, but I do want to try. I think it's possible.
Possible,
well,
yeah,
I,
possible within the constraints of physics. Probably might be a little bit more challenging.
Well, I would have to take a lot
no,
of
but
estimates about where the stars really are, like their positions above the Earth, how big the Earth really is. It's going to take a long time. Clearly,
well, there's something I can tell you is that there's 4 points that I picked in the US in which there's a celestial body. Actually, Jesse picked that one. Jesse Gordon picked those one. But there's 4 points in which stars pass overhead, and you can get the angle of that star from the other points. And if you believe in the 6 nautical miles per degree, you can get the distance between those 4 points, all the 6 distances between those 4 points. And it turns out that the distance you get from 6 nautical miles per degree can't put those 4 points on a flat plane. You get non-coplanar distances that don't fit in a plane, right? So either the 6 nautical miles per degree is wrong, or the Earth is flat. You can't have both, because that gives you distances that are not coplanar. And that doesn't rely on any
globe
math
model,
or
you
anything.
assume an infinite celestial sphere when you celestial map.
No assumption there, no assumption about the Earth or stars. There's no assumption. The only assumption is that there's a 6
Wait,
nautical miles per degree.
come on. You assume a celestial sphere. You don't actually need to know the distances to any stars in celestial navigation. You assume a celestial sphere. It's infinite
I'm
distance
not
each
talking
star.
about celestial navigation. No, I'm not talking about celestial navigation. I'm talking about a specific relationship that you get 4 points. That only assumes, for this, I'm only assuming 6 nautical miles per degree. I'm not assuming anything else. So if there is a 6 nautical miles per degree relationship, I can turn elevation angles into distances. If I do that for 4 points, I can get 6 distance out of those 4 points. And then I can test if those distances match a plane, and they don't. So if those distances are correct, those 4 points are not in the same plane. If those 4 points are in the same plane, then the distances have to be wrong. Therefore, no 6 nautical miles per degree. It's either one or the other. They can't both be true, because that implies a contradiction. You can't have 4 points on a plane that are not coplanar. That's a contradiction. So one of the assumptions have to be wrong. None of those have to do with celestial sphere or anything. It's just 6 nautical miles per degree, and that the observers are on the same plane, and that ends up with the contradiction. But it doesn't contradict the sphere. If you put those same distances over a sphere of 59 miles of radius, they all can rely on the same sphere surface, on the same surface of that sphere.
You wish.
No,
Solid
that's what came
rebuttal.
out of. Yeah, well, that's what came out of what me and Jesse did. Like, I created a web page so you can use 5 distances between 4 points to guess the 6th one, the last one. And you can do that based on a flat surface, and you can do that based on a sphere. And if you get the 6 distances, and you put 5 of them on my website, you get the prediction of the 6th one on a flat plane. And that doesn't match the sixth distance. But if you get the prediction for a sphere, then it matches. So either
But what?
the Earth is a sphere or 6 nautical miles per degree is wrong, right? It's either one or the other.
Oh man, that's why I get like kind of like upset with you, Bacon, because you act like this infinite celestial sphere, like you already mapped out the distances to the stars with your infinite celestial sphere. Like, no, you didn't.
What I just described to you doesn't rely on any mapping. It's just you have a star overhead a person, and other 3 people can read the elevation angle of that star from their location. There's no mapping required.
Yeah, but you act like you're predicting sphericity of the ground while assuming that the stars are in a celestial sphere.
Not in this, let's say, experiment that I just described. There's no assumption of celestial sphere here. Yeah, I do that if I'm doing celestial navigation, but I'm not describing celestial navigation to you. I'm describing using the 6 nautical miles per degree to get distances, and then see if
That's
those
celestial
distances match a plane.
navigation. That's
No, we don't even know the position of the observers. We have no coordinates. All we have is angles. We don't even know where the GP of those stars are.
based
We
on your
only know that they're
GP. Oh man, nah. See, okay, I'm done. Sorry, bro. It's all good. You're always good. See, I know it's possible. I'm gonna get Blender, and I'm gonna actually end up giving it a shot. Like I know what I want to do, so I'm just gonna have to get Blender.
Get Blender. Everybody's getting Blender.
Everyone should get Blender and do their models.
Everyone can get Blender because Blender is free.
That's true.
And they can do their FE models in Blender.
Yeah, that's what we're asking for ever.
No, it's not my FE
Models.
model. It would just be a proof of concept for how celestial navigation can work on a stationary plane.
No, it's just
With
what
sky
Bacon.
rotation. It's not the
It's just
flat
what Bacon thinks. It's what Bacon thinks he can do. It's not what I suggest you do. Just yeah, whatever you want to do, Blender. That's great. It's just not easy to do anything really advanced like you might want to. Like all things, it takes practice and time.
I've used Blender before. I used to have it on my old laptop. I just haven't re-downloaded it.
Nice. I would like to just like it would be nice if somebody just like could set up like all the like visualization tools like in a project to like view a horizon from any given distance within a Blender project.
If we could find that one
I can do
person.
that.
I'm not asking you, Bacon, but it would be cool if somebody could do it that wasn't Bacon.
I'm saying I can do that.
Yeah, if it,
No, you're not asking me. I'm just mentioning it.
I'm excluding you from all of mankind.
Bacon isn't that bad. Are you Bacon? You are mankind, aren't you?
I didn't say he wasn't. I just said I'm excluding him from the purposes of this Blender conversation. No, I'm just kidding. All right.
That doesn't seem very kind.
I'm crestfallen if I can't
I'm not
exclude him.
saying that you're an unkind person, but
I might be.
I will say that if you were, you wouldn't be much different from anybody else, really.
I'd be just like Bacon. No, I'm straw manning Bacon. I'm just kidding. He's not bad. He's
That was pretty bad.
I just have like this amorphous hostility towards him somehow. I'm just joking. It's not really that hostile.
So, is there like
It's
a
bemusement.
personal relationship between the two of you? I'm sorry if
No,
I
he just
seem ignorant.
he just often sounds like past the limit of like where I'm like he sounds super confident, but I'm not sure about any of it. So, but he's consistently at that vector for me. So that's all.
He
Whatever. I'm strawmanning him. Don't worry
Bacon,
about it.
do you have
I'm
Bacon? Do
unfair.
you have what it takes? Do you have the
I
do you have
mean,
the will? Do you have the talent?
the last time me and
What?
Bacon were playing around in Blender, you were so close to what I wanted you to do, man. Like, and then you just stopped doing it, and I was like, what the heck? Why did we stop?
Uh, what was it
What,
doing in render?
what
I
you
don't
were doing
remember.
is you had a flat plane, and you had the stars in a celestial sphere above the Earth, and you were making the star like you were like changing like how far the stars were above the Earth.
I would
Yeah,
actually love to see this because it was a project I would like to work on if I had the skill. Bacon, do you have the skill?
yeah, I
Yeah,
can
he
do it.
already has all the projects in his Blender, and so does Arma.
Bacon, are you this good, bro?
And it depends on what you want me to do. Like, I know some of Blender, but I can do more stuff on web development. Like, if you want to create like an iterative model in which you can play with sizes and distances at will, I can do that in web development. I already created
That's
some stuff.
fascinating.
I'm not sure if you're familiar with this software that I created for selection navigation.
Yeah, I've seen you use it.
No,
Well,
not
you've
you.
also
Yeah, I know you know it, but talking about this. Oh, who's this guy?
should
Not
pull it
familiar
up.
with his voice.
I'm as familiar as I need to be with it right now at this point.
Give you it. It's Livestream one text. You can do selection navigation there instantly. Just put your data and it will tell you where you are. And it's not just elevation angles. It can work off of zenith, azimuths too.
So I see a lot of sextant talk and numbers.
Let me switch my mic.
Bacon, can you tell me a little bit about yourself if you don't mind?
Sure.
Where are you from?
I'm from Brazil.
You're Brazilian. Brazilian times better than me at Blender, apparently.
That was a nice one.
You how long have you been using this program?
I don't use that frequently anymore. But I used it to win the MC Tunes challenge. The smaller one, the $100 one. And I also got a sextant. They also sent me a sextant. Actually, they sent the sextant before that. Yeah, they sent the sextant before that.
I'm confused. Are you saying they send you sex?
Sextant.
Oh,
In
sextant
Monaco sextant.
measurements?
Yeah. No, the tool. Davis Mark 15. They sent me.
Oh, okay. I'm sorry. Um, yeah, wrong subject. My bad. So, well, so you use a sextant?
I used it a couple times.
A little on and off. All right. Is it only in Brazil that you've used it? Do you travel?
I sometimes travel, but I don't take the sextant with me because I usually travel to see my girlfriend, and the sextant case takes quite some space, so I don't take it with me.
Yeah, understandable. Yeah, it's another piece of space, and you know what? You don't want to damage it. And if you use it though, um, what what does it tell you? Like, does it tell you that it's a globe, or does it tell you that it's a flat Earth? What does it tell you?
Oh, it doesn't usually speak, but if I use it treating Earth as a globe, it gives the coordinates that I'm actually at, so it's fine with the globe assumption. I'm not sure what flat Earth assumption I should use to test that, but the globe one is working fine.
Okay. So, how do you use the sextant?
Okay, well, me personally, because I don't live near the ocean, like I don't have a horizon to reference as a 0 degree elevation. I measured the angle between the stars and their reflection on the water, which gives me twice the elevation. So I just half that angle, and I can get the elevation angle like that. That's how I do it. But I
So
prefer
it
to
gives you
do. Go ahead.
it will give you the elevation if you do a mathematical equation.
You mean dividing an angle by 2?
So
I
what angle did you observe to give you the elevation?
Yeah, the angle between the star and its reflection. That gives me twice the elevation angle. So I can't use that angle as an elevation angle because that's twice as big of an elevation angle. I have to half that. I have to divide that by 2. Because the elevation, like the angle to the reflection, is the same angle to the star from level, but it's downwards instead of upwards. So the angle between the two is twice the elevation angle.
So you take the angle and you multiply those angles times 2?
Divide by 2.
You you take the 2, you have to multiply and then divide by 2 to get an average? Is that
No,
what it is?
I don't multiply. I just measure and divide by 2. Because when I'm measuring it, the angle that I'm measuring is already twice the elevation angle. So I have to divide it by 2 to get the elevation angle.
I'm sorry. I don't understand.
Okay, that's fine. I'll draw it. Just give me a sec.
Okay.
Okay, so yeah, can you see the live stream text? I'll post the drawing there. Yeah, just put. Oh, no, it's still uploading. Okay, there's a guy there in the straight line. That line is level for the observer, right? You following?
I'm looking, yeah.
Oh, okay. So I'll send another drawing now. And now there's a water tank below the guy. Right? That water is also level, right? It's parallel to his level line.
Ah, there you go. I
So,
see what you're doing.
right? Are you talking to me?
Yeah, I see what you're doing there now. That little drawing helped me see what you were doing.
Oh, okay. So there's a star in that direction. Send another. I mean, I wish you could live stream that, but I'm drawing in my work computer, and I'm speaking in my personal computer. Okay. So the yellow line is the direction of the star, and the elevation angle is the angle from the white line to the yellow line. Right. That's the elevation. Are you following that? Dude, what's your name?
Witchcraft.
Reflection of the star is I can see the same star in the water. I'll draw on the right. Sorry, this is taking time. Right. Okay, that's my last drawing. So I can see the star from the reflection of the water, right? And the angle from the white line to the yellow line is the same angle as the white line to the green line. So I have like a reversed level. I have a level, the elevation angle that goes down the white line to the reflection of the star. And I also have a side to the star directly, which is the upper yellow line. And then I measure the angle between the yellow and the green one, because I don't have the white one. The white one would be if I had a reference for horizontal, which I don't have. So what I do is I measure the angle between the yellow one and the green one. That is twice the angle between the yellow one and the white one. So I have to divide that by 2. And that gives me the angle between the white one and the yellow one. Does that make sense?
Sounds like an average.
No. I'm not measuring 2 things. I'm measuring 1 thing, which is the angle between the yellow one and the green one. But that is twice the angle, so I have to divide that by 2 to get the elevation. I'm only making 1 measurement and then dividing that by 2 because I'm reading the angle doubled, right? So I have to divide by 2 to get the original angle.
It wouldn't be too much for me to ask you to give me an example. Would you mind?
What do you mean? Isn't that an example?
Yeah, a measurement example.
Oh, you want one of my sites?
Yeah.
Okay, I can give you a moon site. Just give me a second. But I'm not gonna give you more than that because you can then figure out where I live because of selection. See where is it? Have it saved. Okay, yeah, there's a sun site here. I'll send that to you. Okay, so that is the time of my measurement. The what was the threshold? But I was reading the sun. That's why it says sun there below body. The raw angle was the angle that my sextant read, which was 47 degrees and 55.5 arc minutes. And then I divided that by 2 and put that in decimals. So it's 23.9625 degrees. That's my elevation angle. It's 23.9625. So it's half the raw one.
Okay.
Yeah, and I used that with the moon site to get my location and was just 1 mile off, which is incredible. Yeah, gotta have some lunch. So I'll be back later.
Okay.
Hello?
This just in. Earth discovered to be a globe amongst many other globes in the sky.
I
The
think
sun is big and far away.
think we should use the argument that the moon looks closer more often. Because I think it's a very good argument. Right?
The moon looks closer.
Yes.
I don't
If you
know
get
if you made the sun, if you made a moon the size of the sun, and you made craters the size of Jupiter, I think it would look exactly the same.
not the elevation angle wouldn't be the same, no.
The elevation angle, yeah, that would change different.
Yeah, that's what I'm talking about. So if in celestial navigation there's a correction for the parallax of the moon, there's no one for any other celestial body. You're roboting. You're roboting pretty hard now. Can you disconnect and reconnect?
Out of service, crappy service, bad service.
Oh, okay, I can't hear you now. What would you say? What was you saying?
Oh, I was just saying, I was looking at it from like a flat Earth perspective. Like, I'm not going to take any measurements, and I'm going to try and determine how far away something is. I'm going to say it's near and far based on details I can see in the image. So, like, the moon looks close because I can see details.
Right. Well, even without measurements, and I think you kind of need measurements. Because even if you don't accept the corrections of celestial navigation, I can still just wait until someone I know is in the ground position of the moon and see how high the moon appears to me, and do the same when the sun is overhead to that person. And the sun is actually going to look higher than the moon, even though it was above the same point. And I'm still observing that from the same distance. The sun
Oh, I
looks
agree. That's a
higher than
kind
the
of
moon.
measurement, though. That's
Yeah,
a kind of measurement. Yeah.
yeah. But I think that should at least tells you that the moon's closer. Because it looks lower in the sky compared to other celestial bodies.
But do you know what the moon is?
No, not necessarily.
So how do you know what rules it'll follow? Maybe it's through a lens that makes it just appear where it needs to appear.
Right. Yeah, magical lens, right?
It's a lens that can't be mapped out, yet we can use it for mapping.
Shaquille O'Neal just said that there's multiple suns or multiple moons. Multiple.
That
Sorry.
makes
Who
so
said it?
little sense. It's not funny.
It doesn't make much sense.
Who said that?
Sorry, feedback.
At some point, if you could see these, you would see multiple moons. You would see them simultaneously when you got to the halfway point between them.
Yeah, this is the problem I
Yeah,
see
he
with
was
those kind of.
just like he was kind of just fooling around, talking crazy.
Oh, okay.
This is kind of problem I see with those diagrams that say that there are 3 or 4 celestial souths to try to account for they being in opposite directions. Like people in Brazil and people in Australia can see the same star at the same time, looking away from north. So if north is in the center between them, then they are looking away from each other and they are seeing the same thing.
But that's only if you use magnetic north. If you go away from magnetic and you go to some kind of a geopositioning, like or stellar, I can look at the sun and I get to determine north from that. I can do it from geographic points that I know are north of me. I don't have to use a compass. I use a what do you call it? Not a ring laser a gyro compass, which is going to fix itself to the geographic north.
But I was talking about the geographic north. Like
Well,
we.
all of the ones I've seen that they've described that they're always describing it's magnetic is what they say the multiple Earth. They're saying that we don't know which way north is. We don't have a reference. You know, we only use a compass. Essentially, that's what they're saying.
Oh, so you're talking about magnetic declination accounting for like they're both looking at the same direction, but they have different norths. Magnetic
right.
norths.
That's how
Right,
they
well,
look the same direction.
Yeah, well, that wasn't exactly what I was talking about. I was talking about people that say that they're if you're looking, people in Brazil and Australia are both actually looking away from geographical north, but there are 2 celestial souths, one for Brazil and one for Australia.
Oh, okay. So 2 different skies.
Yeah.
2 or 3 different skies.
But the problem is, in which point does the sky split? Because there's only one north, right? And if you get the Orion constellation, it has both stars in the celestial north and it has stars above and below the equator, the celestial equator. So which point did the south stars stop following the celestial equator and then split in 2 so one can be seen in Australia and the other one can be seen in Brazil? Like, I don't know. It feels very impossible for that to be happening without we seeing stars going in opposite directions or they splitting or merging. None of that happened.
Yep.
Not only that, but the angular distance between stars is constant. It doesn't even change. It's like if we were centered around their path, around their motion. Because the angular size is constant. So they can't be getting significantly further or closer to us. Which would imply that we are in the center of their motion in the sky. So if the Earth is big and you have people far away from each other, you can't have all of them being the same center of rotation of the sky.
Right.
But unless the sky is huge and many orders of magnitude bigger than the Earth, so everyone would more or less be in the center, but then there would be no difference in the sky for any. Everyone would have the same sky.
Right.
Like you can't have all things at the same time. Like if you try to explain one thing, then it breaks down something else.
Right. That's where they invoke magic lenses and stuff.
Mm-hmm.
That we all have our own personal dome.
Yep.
My crappy service that I've been having is obviously why I'm out on the road today, because I'm deciding where to put cell sites. So I'm going to all the areas with shitty coverage. Did I drop out again? Test. Test. I'm still here. Oh, bumpy road. Anybody out there?
Yo, yo, yo.
Can't really talk right now. What up, Nate?
Why not? What you doing?
Your mom?
That's fucked up, man.
I'm at work. I'm at work, bro. I'm working with other people right at this moment.
But you always discording while you at work, bro.
I
What's
know,
the?
but there are moments when I work with other people and I just can't.
Yeah, but just tell him to go away, bro. Tell him you on the phone. Like I thought you was a boss at work, Jeremy.
I don't know if you know how work works.
Well, I mean, if you was a shot caller and you was a boss and you was a player pimp, you kind of get to do whatever the fuck you want at work, right? But if you feel like a minion, a bottom feeder, then I guess that's different, man. It sounds like you be taking orders from people.
Bro, there's a time frame. Things need to be done. So regardless of who's calling the shots, like, you just got to do it.
Damn. So today's one of those days.
It ain't one of those days. I do this every day, but it's just for like the first like 30 minutes or so.
Yeah. All right, bro. Well, I mean, just tag me when you can talk, then, man. Because I'm not gonna sit here.
Bro, just hang out, man. People start coming in. Just hang out for 5 minutes.
Yeah, but no one's gonna come in if like there's no one talking in here, bro. We gotta be talking, and you can't talk right now. Like, I mean, just like tag me when you're on your lunch break or something. Unless you had it already, I'm guessing. That's fucking gay, bro. Like, I'm not gonna sit here waiting for people.
Dude, what are you going to do, man? Go listen to them call each other retards and gems? Or
I don't know that other server like popping off right now. Everyone's in there. Howard
yeah, they're
with
fucking no loyalty. No loyalty, motherfuckers. Fucking
but
zero loyalty
everyone's
with these
over
guys.
there.
Some new guys, comes on the scene and just scoops everyone up first fucking month.
That's the way of the world, bro.
That's
People like
fucked
new
up,
new
man.
things. Yeah, I hear you, but like why don't you just come over there, Jeremy? Like what's this
No, bro.
one
We worked,
man?
Nate. We just spent a year trying to get up. Remember at the end of Brandon's and Gems, I was like screaming at people like maniacs, calling names all the time and shit. You
Hmm.
hear me doing that now? I mean, maybe once in a while, but I spent like a year trying to get up out of that, man. I'm not going back into that. And the flat earthers are getting fucked up over there, dude. It's all like, I don't know. No, like fight the flat earth, McToon's over it, goes over it. Them guys are getting their shit rocked when Whitson ain't there. I'm not getting involved with that.
Yeah, but I mean, doesn't that same shit happen over here? I don't know. I
How
don't know.
you guys be getting demoed up in this bitch? For real, bro. You guys don't fucking it don't go down here like it does like it goes down over there.
You sure, man?
I'm fucking positive, bro. It don't go down like that. 100%.
Or if you say so,
100%,
bro.
bro. Huh? That's subjective,
If you
dude.
say,
It's just
yeah, I don't know, man. I hear it get wild here. You know, I hear you struggling to control the room. You know,
when
shit
it
getting.
comes to modding, yeah, I'm talking about the argument. It gets a little crazy here sometimes, yeah. And we got a mod, and people are out of control or whatever. But when it comes to the argument, we ain't getting fucked up like that. I'll
Yeah,
debate you
but
on
that's.
anything right now. Let's go. What do you got?
I thought you was busy working. You couldn't talk.
Nah.
If you
What's
could
up? You
talk,
want
then
this
let's
beef
just
or
talk.
what? You want to set it
I
up for
ain't trying to.
Saturday or something?
I ain't trying to debate you, bro.
uh,
I was just trying to hang, yo. You know.
no doubt.
Yeah, I
No
mean,
doubt.
bro, all that debating and fighting and shit. That shit corny, man. You know, like,
Yeah, but no,
bro,
it's
like,
fun. It's fun to debate some of these topics.
yeah, definitely. You know, it's like fun to, like the whole competitive nature of it. You know,
And you
it's like
learn more.
verbal warfare.
You always learn more. How much have you learned since you came into this arena? I remember when you first started out, bro. It's so cute. You
Get
were
the
such
fuck out
like
of here, dude. I
you were
remember your
so
first
green.
day in Gems, bro. You found me here. What do you mean?
What's
I
up?
remember. I remember your first day in Gem Panda server when you was brand new. You found me
Yeah,
here,
I remember when
Jeremy.
you were brand new too. It was cute. You were
What do
doing.
you mean I was brand new? Jeremy, you didn't even know me when I was brand new, bro. You
Well, it took you a
found me
long year to get. It took you a
a
long time to
veteran.
get. It took you a long time to get not new because I mean, you used to get wrecked over there big time, bro.
By who? Who
Remember? Do you
wrecked
remember our
you?
apple conversation about the apple and how the tree grows? You don't remember that? I'm gonna go find that someday. It's
I
on Chemo's channel. I'm gonna
vaguely,
go find that and show you how silly you used to be.
yeah, I vaguely remember it, man. Something about an
Yeah, bro,
apple.
you got wrecked that day. I remember that crystal clear.
What was the debate about? Where does an apple get most of its mass from, or something?
We were having like it was like relative density or something. It was like the main topic, and you were trying to use an apple or something.
Oh,
And I'm like, bro, all the stuff that
yeah,
made the apple came from the ground. You're like, no, it didn't. I'm like, bro, it's all water. It's almost all water.
yeah,
And
but
you're like, no, it's not like you. It was just crazy what you were saying. You're like, oh,
yeah,
it's
but
made
what
up
I'm
of the
saying,
gases in the air. I know you tried saying something crazy.
yeah, but that is true. I mean, it does get nutrients from the gases in the air around it, not just from the water in the ground,
Yeah, but the argument was most of the stuff the apple's made up of came from the
man.
ground.
I don't know if that was the whole entire argument, man.
Yeah, because you're like, how'd the apple get up there? I'm like, bro, it fucking came. Everything the apple's made of came from the ground, bro.
But you don't even believe in relative density anymore. Like you never talk about it.
No, that's definitely, bro. I've had so many debates on that. I bodied Jace on that one. Are you serious?
Get the fuck out of here.
Jace, Jace Hood, he got fucking scraped one night. Oh, I think it was in Brandon.
What?
You can't fuck with me when it comes to relative density. Are you out your mind?
I'm gonna ask Jace about this, bro, because you be saying shit a lot that ain't
Bro,
100% true sometimes.
Bro, Jace got bodied. I used to go bring it to him all the time in gems. All right, I have these guys scrambling, bro. Because it's subjective. Relative density, it's subjective. Even you guys that have it, it's called specific gravity. Like, that's not even an argument about what happens there.
Yeah, I mean, relative density is a basic explanation for things, but it doesn't, cover all known situations. There's some situations where relative density just doesn't, cut the mustard, bro.
Yeah, there's some things that don't work with it. I know that. Like the
Yeah,
gas doesn't work with it.
yeah, or when you in a vomit comet, like relative density got no business explaining what happens in the vomit comet.
Well, yeah, when you're moving crazy, yeah. If you move the relative density tower, yeah, the stuff's gonna get mixed up. Yo, I
Yeah.
gotta go. I'll be right back. Give me like 5, 10 minutes.
All right, bro.
Get him, snacks. Keep him on ice for me till I get back.
All right, now Snacks chill. Snacks ain't about that fighting and shit. Snacks ain't built like that, man. I got dogs to feed. I can help you with that. He even ran. You see that? He fucking hamstringed, bro.
You didn't want that beef.
He didn't want that smoke, man.
Set
Yeah.
it up, bro. Anything.
You and me? Do you want to debate me, Jeremy?
Pick any topic.
All right.
We can
You
talk
and
about
I are gonna
anything
have a
about the
debate.
topic.
Okay, you and I are gonna have a debate on the weak nuclear force this Saturday, right?
I don't know. I don't know if Saturday is good for me or not. I have to check my schedule.
So which days are you normally free, bro? If you work Monday to Friday, and then you like on
I'm gonna
daddy
check my
daycare.
schedule, bro. I'll get back to you.
All right, man. And there's no point because this ain't gonna happen, man. You're always busy with who knows what. You prioritize your family over Discord, bro. It's kind of fucked up. Man. Uh,